Hello, welcome back to BlenderSushi Live Noding. Today lesson, I was inspired by this video by Daniel Shiffman the other day. He was doing this processing code challenge number 30, Phyllotaxis. Basically, he clearly explained the whole thing in his YouTube video, and then explaining about Phyllotaxis, and then like the number pattern and algorithm that's he source, and then he codes using processing to get kind of like the pattern you often see in the sunflower. This is not something new, but every now and then I found this kind of case, and since I don't think anyone else have done this for animation nodes, I could be wrong, but this is something that we could investigate using animation nodes, and this is a very interesting case study or exercise. The math behind it is already explained clearly from the if you find it in a math book or in the website that Daniel Shiffman kind of mentions. It's a algorithmic botany. Yeah, so clear. But I also wanted to show it to you that we already have it inside Sverchok. So I kind of like I already have all the cheat, the formula to get to where we are gonna be. So I'll just gonna show it to you. It's a fun exercise. Sometimes you don't really need to worry about the math formula. You just need to think about, okay, this recipe or algorithm is good to create this kind of pattern, and then you can reuse it in your own work. Okay, I'll just gonna show you. Start from Sverchok. Sverchok already got it in the generators scripted node, and if you can find it here, spiral Fibonacci.py. So I'm gonna load it, and I'm gonna click on this import, and if we look at the text, we got it here, spiral Fibonacci, or yeah, and let's just create the node. So this is Sverchok scripted node. To be able to see the result, we just need to use like a viewer draw. And how many? It's gonna generate 1,000 points. Let's try 100 first, and then have a look. So we got the Fibonacci or the sunflower or the Phyllotaxis thing happening already, and we can play with the scale factor. So yeah, that's cool, and we have everything already. But I'm going to recreate it using animation nodes anyway, just for exercise. Okay, good exercise. I love just like the math pattern and algorithm, always interesting to create in 3D. I'm gonna hide the lamp and the camera. I'm going to keep this Sverchok script. Maybe we can just reuse some of this. So where do I start? I'll switch to animation nodes and create a new node 3. I'm going to save it. And Phyllotaxis. So I'm gonna start from scratch, and I will create a script node. It's an empty script node, but soon we're gonna kind of translate this into animation nodes version. I can hide this for now. So I'm gonna create a new text. That's gonna be our script, and then I'm going to load it right here. Okay, so what do we need? From Sverchok node, we just need to provide the n, the number of kind of iterations it's gonna create, and then c is gonna be the scaling factor for the Phyllotaxis or the Fibonacci points. And yeah, everything else is straightforward. The formula is already here. We can even copy paste it. Yeah, let's start with the input. Okay, with the inputs, let's say for the number of points, it's gonna be an integer, and I'm just gonna call it n as well, just like the Sverchok versions. Scale factor is gonna be c, so it's gonna be float. Floats just mean like a decimal numbers, and then the output's gonna be, of course, the x and the y, x and y. And then normally I will just create the node right away and then see what's complaint we get. Name x is not defined. Maybe we just gonna define the x and the y, so it's not complaining anymore. And then the next we're gonna kind of look at this formula for I in range 0 to n, and then we have the formula already for the angle. Theta I is the iterations times radians, and then the number. This is like a special number or special angle, and then we're gonna type the rest of the code. Square root I, square root I, and then it's gonna result in the x and the y. The x is gonna be radius times cos theta y equal r times sine theta Yep, that should be good. And then I think we have everything. Let's see. Let's save this and then let's have a look. Okay, still complaining. Name radians is not defined. So this is something like with a Python code, you need to import the module for math, or from math import sine, cos, radians, square root. We don't need the pi. Do we need the pi? There is no pi, so just leave it like that, and then let's have a look. So if using the formula, it seems everything is ready. Let's just use like an icosphere, and instead of always calculating, turn off always, and then just turn on frame change or property change. Okay, let's say let's transform. I always test it using object transforms input, and grab that object, and that's the x and the y. It's gonna output something, and then we need a vector for the points position. Vector input is we try plug it in, so we already get it. So now we can test it. Seems to be doing what we need it to do, and we have the scaling and stuff, and then so this guy is kind of moving in a pattern of Fibonacci or the Phyllotaxis, just like the sunflower. But here I don't need to see the script anymore. We can hide this script. We don't need to see the Sverchok script. We just have the animation nodes. what I can do now is just like creating duplicates. We're gonna instance this guy, the icosphere, into like a sunflower pattern. Okay, and for that we need a loop. For the loop input, let's see, the index we can plug the index into the number here, our formula. So this, I'm gonna give it a color, different color, to be clear. And the icosphere, we're gonna need to be instancing that guy, and the vector will generate the points we need. Let's get our loop. So this is our loop, and then instance the object instancer. Let's grab this guy and then plug that in. How many instances? Let's make like 10 for now. So it's starting to happen, this Phyllotaxis thing. I'm gonna scale the master and put it aside, reduce the radius, the scaling, and increasing the instance. So there you go, we got the sunflower kind of pattern happening. 250 should be good for now. Let's hide the relationship lines. Tap U and then hide relationship lines. So that's kind of good. We are pretty much done, but I would like to do something more. Let's see. Let's save this. You see, such a simple formula can get you to this kind of beautiful pattern quite easily. And the nodes itself is really quite simple. Yes, this is one of example where if you find like a formula, math formula or algorithm on the net, and you transfer it into nodes, and you get something like this quite complex pattern. And okay, what am I trying to do? Let's see, if you want to, let's say you want to animate this, maybe using the scale, you can do that. Remember the other day when we are using like a mix node, and we can use also animate vector. We can apply that here. Okay, let's see, frame, plug into time. Start is gonna be 0, end gonna be 1. Durations doesn't matter. So now if we animate this, let's create a timeline here. So that's animating, but it's animating the whole thing at the same time. We want to stagger it. We use the index. Let's use ma, and we're gonna delay. Okay, delay time. And for the delay, we're gonna use the index. And so we play back. It's looking like that. And continue on. So that's quite beautiful. You can actually animate the instance number here. I'm not gonna do that. And so that's for the center part of the sunflower. Maybe if you have like a leaf kind of design, you can get like the petal thing happening. So let's try to create a petal. Start from a circle. So that's a circle. Let's make like just 16 points and create a face. Now let's scale this in X and maybe I'm just gonna scale it down. Turn on 3D cursor and scale it in Y slightly, and then maybe more. Wait, SY, and do that. Scale it in X. Oops. Like that, so it's more like a petal, and we can use something like this to instance our Phyllotaxis points. So instead of icosphere, I can use that guy and then have a look at the result. So that's what we get. I can turn on ambient occlusion. Cannot see anything because they are like overlapping, and they are also facing the same directions. I want the petal to be facing outward, so let's try plugging in the vector into the rotation. Let's hopefully we get what we want. Maybe, yeah, so that's pretty much what I want, although I probably need to maybe stagger the Z direction slightly and maybe rotate the flower so it's not flat. Let's rotate it. Euler math might be it. So Euler math. There it goes. We're starting to get something. It's kind of spiraling. There you go. It's almost like a kind of like a flowery pattern. Yeah, it's really beautiful. And if we continue, let's maybe like that. So that's kind of complex design. It's like a flower. If I'm not wrong, there's actually like a plugin. I remember there's a plugin called Phyllotaxis that does a lot of kind of plants kind of design. It's all related to L system, kind of like a way for you to generate plants or trees or flowers, and yeah, all like a beautiful things from nature that you can recreate using computer. The math behind it is kind of complex, but the mathematicians have worked out the formula, and then all we need to do sometimes just to use it. Okay, so there you go. What else should we do? Maybe to colorize the flower. Actually, there's something we can do. This special angle here. Let's say if I add one more variable or parameter or attributes here. Okay, let's reopen the script node creations and then add a new input and call it a magic number float. call it magic. The magic number is 137.5 degree. So float input 137.5, and I just plug that in and just replace this number with magic. So it should still be working. If we slightly change the number, you see the pattern changes, and we get a different result real quick. That looks more like a palm tree now. That's really interesting. Yeah, just slight variations. That's for you to play with. In fact, it's more resembling the lotus flower as well. Yeah, my mom is actually quite a big fan of the lotus flower. It's kind of interesting. With this angle right here, I think we can use like a curve interpolations to get the angle to change the value. So we have something that's more like a flower. We can let's see quickly think. So it's Euler expecting vector, so combine vector -6 here. So that's the Z, and the angle on the X is that's the one that's interesting. See, it's doing like a funny flip. Maybe it's but yeah, that's funny thing. That's cool. But what we really want is to make it facing. See, I'm just trying it out, trying all kind of combinations here. Euler, do we have like combined Euler? We actually have combined Euler here. So that's actually Euler, it's not a vector. Use degree or not? Yeah, use degree. Doesn't matter, just give it a try. Use degree. The X, okay, the X, I don't know what's the X gonna, but I want it to go like it should be like a different angle as it grows to the top. So let's try using the index. Okay, the index giving, that's actually looking like a like a lotus flower. We need a bit of math here. Index goes from 0 to the last one, and then have to think. Map range, plug into the value, input max, probably. Just kind of guessing. Input max is probably the topmost. The angle should be, yeah, something like that. The last number, if we plug this into that, yep, this is actually what I really want. So I'm pretty happy with this. Now we just try giving it like different color. I guess that's pretty cool. So different color, how do we do that? We have the leaves here. We don't need the icosphere anymore. With this leaf, as you already know, I use this technique all the time for Blender render. Just create a material and then enable object color, and now we can colorize it. And using object attribute output and color. So the objects is gonna be this guy. As you can see, we are using location, rotation, scale, and then extra attributes. Almost like all attributes of an object. Later on, maybe when we have more control over the point custom attributes or objects, other object attributes, maybe for a rig, we might have more. So, but this is it's kind of fun to think of all this system. So the color, what do we have? What are we gonna do? We can use the technique from the other day where we have like a bunch of color lists. So mixed color list is something I will use. And let's see the vector color list. Okay, let's make a color list. Create a color list. Color red, orange, blue. I don't know, I'm just maybe not the best color combinations. Red, maybe magenta, red to purple to kind of blue. That's probably better looking. I'm gonna mix that and finally plug it in. So we're gonna see a magic happens when we turn on the deep copy and copy full object. Nothing is happening. That's because of the factor here. The factor, in fact, the factor goes from 0 to 1. So we can use another map range node. Map range. What's the range we got? The value we're gonna get from the index. Index goes from 0 to the maximum number of objects. The output goes 0 to 1, so plug this into vector. So there you go. It's working, yay. I'm pretty happy with this. We could increase the instance to 400. And seems to be working pretty good, 500. You can have more, but let's keep it 400. Everything is under control. The C is the radius, scaling the radius maybe less. This is like lotus flower, normally used in the religion like Buddhist. This really beautiful flower. That's what's the god? The lady god Kuan Yin like to sit on in the middle of giant lotus flower, something like that. This red can be yellow. Or orange or red. Yeah, so it's now just play around with the number. I want to get the angle just right, but that's just a matter of tweaking. So can I make it like that? So okay, there you go. It's kind of our explorations of the Phyllotaxis. Thank you for Daniel Shiffman video tutorial. I really admire that guy. He's a really good teacher teaching processing, even though I'm still like learning processing at the moment, and but you know, it's my side learning thing while learning 3D. Here, you know, with the color you can continue playing around and get a different result. Maybe try yellow, and that's cute. Didn't change. Maybe I should have more. Seems to be interpolating from 0 to 1. That's right, different color. Okay, got it. So I need to have like more output max, and there you go, kind of a beautiful flower. And it's not about the complexity. Of course it's about the result, but it's really like the process to get to this kind of result is much more interesting, I think. Yeah, so I found this really like quite elegant setup. Created using animation nodes, and we started with just these nodes, like a script node that kind of create the Phyllotaxis points, and then we further on we instance the leaves into the points, and yeah, I guess that's it for now. Hope you like this video and find this to be useful for whatever you're doing. If you like the video, you can leave comments and give like a like, and you can subscribe to the channel. I'll try to make more video.